everybody. I'm Farshad Tahmosebi. I'm consultant obstetrician and gynecologist, and this is the third part of CA125. I hope you have watched first and second parts. This time we jump into our presentation straight away, and I asked my colleague Wassal to take over.
Okay, hello everyone, and welcome to the third lecture. So in the previous two lectures, we talked about CA125 and how it was discovered. We also talked about the role of CA125, or also known as MUC16, in ovarian cancer, but also in different gynecological conditions and its response to stress. So that's mechanical and also inflammatory stress. In this lecture, we will delve more deeply into the different types of mucins and the role in cancers and also in inflammatory conditions. So in this lecture, we will start off by giving a bit of a recap on the different things that we covered in the previous lectures about CA125 and mucins. And then we will talk more in detail about mucins in cancer, and we'll be focusing more specifically on mucin 1, mucin 2, 4, 13 and 16. So in the first lecture, we talked about what is CA125 and how it was discovered. We talked about the discovery of the OC125 antibody by Dr. Robert Bast and his colleagues, and how that resulted in the identification of this molecule CA125, which was then used to develop a blood test. We also talked about how the cutoff level was identified. If you want further details about this, I would advise you to go back and refer to the two lectures that we've done previously. We also talked about MUC16, how it's found in different areas of the body, and its physiological role, as well as its role in response to stress and in benign gynecological conditions. So we'll start by saying what mucins are. So mucins are basically proteins which are heavily glycosylated. They are produced by epithelial cells. And when we say that they're heavily glycosylated, what we mean is that they have a lot of glucose molecules attached to them. And this is very important because it helps to serve the role as a lubrication molecule, which serves for protection of epithelial tissues. They have a high number of these two amino acids called threonine and serine, as well as other amino acids, and this is very important because it helps formation of bonds between the proteins and the sugars. As I previously mentioned, they have sort of two key characteristics, such as lubrication and also the formation of chemical barriers, but also involved in cell signaling pathways. So there are two families of mucins in humans. So there's the secreted mucins and the transmembrane mucins. So the secreted mucins are secreted into the mucus gel, and the transmembrane mucins are stuck to the cell membrane, as demonstrated in this diagram here. So secreted mucins include things such as mucin 2, mucin 5 and mucin 6, and some of the transmembrane mucins are mucin 1, mucin 4, 13 and 16. Mucins play a very important role in inflammatory conditions, such as in inflammatory airway disease. Overproduction of mucin and hypersecretion of them are associated with contribution towards the airway obstruction. And in the context of cancer, the aberrant expression and also aberrant glycosylation of these mucins contribute to tumor survival and proliferation.
Because of that, in ovarian cancer, for example, we have overexpression of MUC16, and we know that the higher the level of CA125 or MUC16, the more chance the tumor can survive and metastatize.
Mucin 1 is also known as polymorphic epithelial mucin, or epithelial membrane antigen. It's, again, just like other mucins, has a protective role, so it binds pathogens and also it works in the cell signaling pathway. It has an important role in cancer, so it inhibits access to chemotherapeutic agents. So as I mentioned before, these proteins are heavily glycosylated, so there's a lot of sugar molecules, and this creates a hydrophilic environment However, a lot of chemotherapeutic agents are hydrophobic, so this will prevent access to the cancer cells. They also prevent cell death by prevention of apoptosis through interfering with cell signaling pathway, and also promote tumor invasion. They also interfere with tumor invasion pathways within the cell by interfering with the beta-catenin and a WNT signaling pathway in cells, which has a very important role in cell proliferation, differentiation, and apoptosis. Mucin-1 is also used for blood tests such as CA125 and CA15.3 in breast cancer. So both of these blood tests are epitopes on mucin-1. CA127.9 has higher specificity and sensitivity compared to CA15.3.
As my colleague also mentioned, the higher the level of mucin, the more resistant they are to chemotherapy. We know that in ovarian cancer, the higher the level of CA125, the less responsive to chemotherapy, because they create hydrophilic environment, and chemotherapy agents are hydrophobic, and as a result they don't respond to chemotherapy very well.
Okay, so now we'll be moving on to mucin-2. So mucin-2 is very prominent in the gut and is secreted by goblet cells. In the context of inflammatory bowel disease, interestingly, mucin-2 expression is downregulated, and this is thought to contribute towards the inflammatory process seen in conditions such as ulcerative colitis. So there is the downregulation of mucin-2 is thought to be associated with loss of integrity of the mucosal barrier, and this increases infiltration of microbes into the mucosa, therefore resulting in more inflammation. In the context of colorectal cancer, there is a reduced mucin-2 expression, whereas, for example, in ovarian cancer, we see increased MUC16 expression. And, this is all very confusing. And of course, we still need to have some more studies and research on this to try and explain the different interaction of mucins in different contexts and in different cancers.
Just what we are trying to highlight in our lectures, to make sure you have a very good understanding of not only MUC16, also other family members such as MUC1, MUC2, MUC4, because we think if you know very in-depth knowledge about MUC16, it will help you how to interpret the test when you are in front of the patient, and not necessarily you think straight away about ovarian cancer when you have 42 years old patient with fibroid endometriosis and CA125 of 80.
So now we'll talk about mucin-4. So it has a disadhesive role, and it promotes lubrication in the respiratory tract and also in the reproductive tract, as well as in the visual and auditory systems. In the context of cancer, just like other mucins that we've discussed previously, it again represses cellular processes such as apoptosis, and also alters the adhesive properties of cells and disorganizes the extracellular matrix, which is thought to promote the tumor invasion and metastasis. In the context of esophageal cancer, there is an increased tumor migration and proliferation associated with high levels of mucin-4 expression. And studies have shown that the inhibition of mucin-4 can reduce tumor proliferation and the tumor size. And this is very good because it means that we can perhaps develop specific therapeutic agents against mucin-4. In terms of breast cancer, interestingly, what we see is that there is a down regulation of mucin-4 in the primary tumor. However, in the metastatic tumors, for example, in the lymph nodes, there is an upregulation of mucin-4. And this is thought to be that due to the change of mucin-4 in different contexts, so that it can promote the tumor invasion and metastasis.
Also, just a quick reminder, in ovarian cancer, overexpression of MUC16 helps tumor metastasis and invasion. What we believe from research and papers that mucins in general because they disorganize extracellular matrix. They help tumor invasion, and as a result, they promote metastasis.
So in the context of pancreatic cancer, there is overexpression of mucin 4. However, this is not normally expressed in normal pancreatic tissues, again supporting its role in the sort of cancer in terms of tumor invasion and metastasis.
It appears that overexpression of MUC16 and MUC4 all contribute to metastasis and tumor progression. In colon cancer, on the contrary, we have the downregulation of MUC2. Maybe this is something just to remember or to think about.
So now we'll talk more specifically about the role of MUC16 in tumor invasion and metastasis in the context of ovarian cancer. So interestingly, mucin 1 and mucin 16 are structurally very similar, and they're both known to promote tumorigenesis. So in terms of promotion of tumor progression and metastasis, mucin 16 does this through various mechanisms. So it interacts with beta-catenin, which is involved in the WNT signaling pathway. And this pathway is involved in different cellular processes which promote things such as apoptosis, migration, and invasion. It also selectively binds to mesothelin, which is essentially a glycoprotein expressed by mesothelial cells of the peritoneum. And this enables the tumor cells to stick to the peritoneum and help the tumor invasion and metastasis. It also induces mobility of the tumor cells, so it's thought that the cytoplasmic tail, so this one here, within MUC16 facilitates signaling within the cells and decreases expression of things such as E-cadherin and increases N-cadherin and vimentin. And this expression pattern is associated with the epithelial to mesenchymal transition seen in cancer. It also interacts with the immune system, so interacts with proteins such as Siglec-9, which is found in different immune cells, and this acts as an anti-adhesive agent to block the tumor cells from interacting with immune cells. And as we previously discussed in the previous lectures, it also inhibits the interaction of natural killer cells. So in summary today, we've covered mucins and how they have a protective role physiologically in different epithelial tissues. And we talked about how their overexpression in cancer can facilitate tumor invasion, but also, interestingly, there's also downregulation of mucins in some cancers, such as in colorectal cancer. And this is associated with poorer prognosis.
I hope you enjoyed these 3 videos about CA125 or MUC16. We covered in general how it has been discovered, how we use CA125 in different scenarios, how we actually measure CA125 in blood with immunoassays, and also we discussed briefly regarding the CA125 in physiological conditions like menstruation, pregnancy, gynecological, non-gynecological cancerous and non-cancerous. In the next video, we are going to specifically discuss in more details about those conditions. In next video, we are going to discuss about CA125 and the role in pregnancy, miscarriage, preeclampsia, and ectopic pregnancy. Thanks for watching, and please leave your comments. We will get back to you. And I would also like to mention that if you want to participate in our educational videos, please leave me a comment or leave me your email, and we will get back to you, and we can see how we can work together to make it more interactive.
Okay, thank you for watching our videos. If you have any suggestions as to which topics you would like us to cover, please leave below any comments, and thank you.